Hello, I'm Sena Yao Acho, a student at Chukwuemeka University, Turkey. Today, I'm here to present on the topic a review of some physical and mechanical properties of cassava related to harvesting and processing machines. Graphical abstract. Today's presentation is briefed on this graphical abstract. First figure, as shown on the slide, is a typical cassava plant. It's more like any other plant that has the leaves, the stem, and that of the root system. In cassava, this is the root system, and it is the most important part of the plant, although the leaves are also consumed. But this particular section is the most important part. Moving forward to the slide, we also have this figure which represents the morphology of a cassava. The first part, which is A, is the general morphology of cassava, whilst the B is the transverse section of a cassava. Whilst we move downward in this direction, the third part are methods for harvesting cassava. And this particular one is the traditional method for harvesting cassava. As we move alongside the chain, we have the fourth figure, which is the engineering properties. What does this engineering properties mean? It therefore means that before we can manufacture the fifth or the last figure, which is a cassava harvester, you must know some physical, mechanical, chemical, aeronautic properties of the cassava before it can be manufactured. Problem statement. Harvesting of cassava is very tedious, and there has not been a well-designed machine to harvest the crop, neither to separate nor convey the crop in one-time operation. So therefore, there is a need for a concrete harvester to do the process. Objectives. The main objectives of the study is to review qualitatively the physical and mechanical properties of cassava. Secondly, to review some harvesting methods for cassava around the globe. End product of cassava. Some may ask, what is this cassava at all? Cassava was originated from South America, and up to now, it has been a staple crop in Africa and some part of Asia. For instance, Nigeria is the largest producer of cassava in the world. Some of the end products of cassava includes flour, that is for making of bread and pastries. We have starch, ethanol production, animal feed, food, that is human consumptions, pharmaceutical products, and many others. Engineering properties of cassava. It is very important that the first step to design any machine, you must know the engineering properties. And as mentioned earlier on, these properties are very useful and necessary in the design and production of agriculture equipment and farm machinery. Now, physical and mechanical properties. For the sake of this project, my main concentration will be based on physical and mechanical properties. So as seen on the slide and on this table, these are some of the physical properties that are to be determined before a machine can be manufactured. For instance, the angle of repose is very, very necessary because it helps in the design of a hopper or a chute for any agricultural machinery. Likewise, the mechanical properties such as the compressive strength and compressive stress, the shear strength and the tensile strength are all necessary in the design on any machine. Harvesting of cassava. Cassava harvesting is grouped into two main parts. We have the traditional harvesting method and we also have the mechanized harvesting method. On the slide, in the traditional harvesting method, it has also the normal traditional method and the semi-manual method. For instance, the first figure that we see over here represents the traditional method. But in this method, we can see from the figure that only cutlass, mattock, or hoe are being used to harvest the cassava. And I might say it's very difficult because a lot of energy is needed to uproot the cassava from the soil. Now, when we look at the second figure, it's also a manual method, but it's more like a semi-manual because a device is being used to assist in the harvesting process. And this device is being hooked to the cassava plant and a force is applied to uproot the cassava. The device works on the principles of a lever to uproot the cassava. Now, in the next slide, we also have the mechanized method for harvesting cassava, but this particular one, we call it the fork shear blade type, because when you look at the blades over here, it looks like a fork. But concerning the second part, we also call it the curve shear blade type. It also looks like a curve when you look at this part. Someone may ask, what are some of the advantages and disadvantages of this type of semi-mechanized harvesters? It's true, every machine has its own advantages and disadvantages. For instance, the fork shear blade type, there is a minimum damage of the tuber in the soil as compared to the curve shear blade type. The next slide over here is also another type of harvester, but this harvester is hitched to a tractor and we can see that it's also using an hydraulic system. And this hydraulic system will aid the upward movement and the downward movement of the implement attached to it. Now, in this slide is also another harvester that can be seen over here as one, and to another harvester. They are all hitched to the tractor to assist the harvesting process. Now, the last harvester is also shown on the slide. This particular harvester is an improved or a developed harvester, which it's very, very vital because it's having a conveying unit and that of a digging unit. And it has a PTO system over here, which is being attached or hitched to the tractor. Now, merit and demerits of mechanized harvesters. So based on the mechanized harvesters, we have its own merits and that of demerit of mechanized harvesters. For instance, we could see from the slides that some of the harvesters, they have a conveying unit, but others do not have a conveying unit. And we can also see that some harvesters have an hydraulic system attached to it, whilst others do not have hydraulic system attached to it. Now, in conclusion, there should be a research which is directed towards the area of loosening the soil, or the area of loosening the crop in the root zone, thereby lifting out the tubers with minimum damage, because it's very necessary to research more on it so that there should be a minimum post-harvest damage. And I'm also recommending that likewise we have combine harvesters that are used in harvesting of maize, rice in one-time operation. The same research can be done so that in cassava production we may have an equipment that may be used in one-time operations. For instance, there have to be a cutting device that can be fixed in front of the tractor that will do the first process of cutting of the plant, and at the back or the rear of the tractor there can be the harvester that will aid in the process. So in that situation, there will be a one-time operation of the process. Thank you very much.